Right, welcome to this session. Can you hear me all right? Even back there? Yep. Okay, so welcome to the session about reasoning over your code and metadata. As I hinted before, this is not a session like many others that you have seen. It's not something where we talk about a particular API or talk about timesheets or costing or accounting, stuff like this. This has nothing to do with that. This is something to whet your appetite and inspire you to go solve problems on your own. So none of this is yet baked into any development tool, so you can just go home and use it. You just didn't know the switch was there. No, that's not what this is about. So with that in mind, let's get started. This session is not for everybody. What you will learn here is to extract information from your AX artifacts, be it metadata and code. And we will show you some easy reasoning that you can do, and maybe some things that you didn't think about before. I think I will show you 2 or 3 things that you have never thought about before, and you will learn to apply those in the space of AX. That's my hope, that you will take that away from this presentation. Will this allow you to go home and solve a problem that you couldn't before? I hope so, but it's up to you. It's not something that I'm here to present and say, we've done this, now go and use it. All right, I think I made that point now. So we're going to go over the basics. We're going to talk about reasoning over metadata, and then we're going to dig into the X++ code reasoning, what that means. We'll be talking about some different ways that you can leverage cross-reference information. And then we have some surprise material that is the most important thing that we're going to talk about. And it's going to be an aha moment for you. It's going to be an epiphany. It's going to be great. And, I didn't even put it here because I didn't dare put it there, what it actually is. But we're going to end this on a high note with some possibilities that you didn't think about before, and that has enormous potential in the way that you solve some of the problems that you have in your organization. I promise you that. So there are many good results to be reaped from this. Who am I? Peter Willitsen, you know me, maybe some of you. I have been in this space longer than I care to admit, from back when I had hair. I work with the AX development stack. I have been working on the X++ compiler for a long time. I own the AX development story with the debugger, best practice tools, IntelliSense engine, editor, all that stuff. And I've been transitioning into the CDS space more and more. And the Maker portal and some of that stuff I own as well. And I promise you in this session there will be no athletics. Okay, reasoning over metadata. So this is what I call the basics. Let's just get our limits right here. So metadata is a large part of what we do in AX. In fact, it's the defining part. I like to say applications equals metadata plus code. That's what an application really is. And today, in the new world, that is, well, it's not so new anymore, but in Dynamics 365 for operations, metadata is just stored as XML files. So these XML files are open to you to do whatever you want to do. Normally, of course, you interact with it using the AOT or the Application Explorer in Visual Studio. That's the editing surface that you use, and you edit there and consume it in various ways. So before we start digging into reasoning about this, a few questions you may ask are these. Why do I care? Who cares about reasoning over metadata? Well, these are things that I hear in my daily life as well. There are cases where you need to extract information and do something with it. You can do ad hoc questions that you want answered. I have a table, I know it has some property set, but I can't actually find that because I have 5,000 tables and I don't remember which one. Could you just find it for me? Well, we have to have a way to answer that question. And what you'll learn here will certainly be able to answer those questions. There's also reports that you may want to make on different things. Or you may want to write tools. We'll go over a few add-ins that you can write and provide a lot of value to your customers that way. So there are several ways that you can actually reason over this. One is you can use the dict classes in X++. You can. You certainly can, and there's some code out there that does that, and it'll keep working. But it only covers what it covered in AX 2012. We haven't put the new stuff in there. So it'll work in X++. You could use tree nodes, but you don't want to go there. You can use a general-purpose C# metadata API that I will show you in a few seconds, and that's actually what the tools that we have written, the compiler and all that stuff, what that actually uses. And it's surprisingly easy to use, and it's very complete, and I'll show you how to use it in just a few seconds. And you can use raw XML APIs that reason over, or that read the XMLs and then query over it with XPath and XQuery. And there's a final thing that you can do, but I'll keep you in suspense because it's so cool. So once I've talked about this, the last point, you'll say, why did you even tell us about all this other thing? So let's go here to my... Oops. Okay. Here. So let's just show an example. Oh, come on. Can you read the code reasonably well? Okay. So let's take an example where I look at a root path, and then I do a metadata reader that traverses all those XML files and reads them and builds a dictionary. And then I'm going to do XPath over that XML document to find all the developer documentation. In this case, I want the ones that don't have any developer documentation. So let's run that and see what falls out of this. Okay, stopwatch there. Let's see how much time we spent doing that. This machine is a nightmare in terms of function keys. So we spent 136 milliseconds reading the whole of fleet management metadata. Now, that's not too bad. And in fact, if there is a secret sauce, as the Americans like to say, a secret sauce to AX, it is the fact that we are building on the XML experience, which is so incredibly rich and so incredibly performant. That's really the crux. That's why everything works. If we didn't have this, we would be stuck with storing things in databases and so on. It's a really important point. And I tried to prove it here. So let's go over each one. And now I'm going to XPath search over the table and say which one doesn't have a developer thing. Okay, let's just see what it writes. No developer doc for FM address table. Okay. Let's continue that. You get the point, right? So this is a case where you simply use the raw XML data that you have to good effect. It just works. But it's not very type safe. Right? It sort of strings everything, and it rubs me the wrong way. I don't like it. Let's see what else we can do. Go away. This guy. So let me show you the APIs that we actually use ourselves for the compiler and for everything else. There. So short and sweet, this is what happens. You create yourself a metadata provider that looks over a particular place in your tree, and then you can work. I'll show you how it works. Now would be a good time. There. And this says, from this metadata provider, give me all the tables and list all the tables that are there in the package called Application Foundation. So let's do that. Let's look at L. Has 591 tables in there. And these are all the tables that it has. So these are flat names. These are just the names of the tables. But we can do so much better than that. So let's ask for a particular one. I took this content type, I don't know why, it was just a particular table. So do that. And now we have a completely high fidelity, super high fidelity object model that defines this piece of metadata. So here you have your attributes, and there are none here. But let's go to fields. Here. Fields, you can go look at what the fields are. There are only 2 here for some reason. It's a little strange, but maybe it's true. You can even see the source code, and the declaration is up here. Well, okay. Not exactly going to get your pulse up, but you see how this object model is very rich, and it's fully type safe. So now you can go ahead and do your queries with link over this object model that you are given. So that's a very, very powerful way of doing it, and as I said, it's the underpinnings of everything that we do. To give you an example of what it is we use this sort of thing for, I want to show you something that I want you to take home and actually use in your org, because you probably don't know it's here. I open some table in the view here. This is account BR, it doesn't matter. I go here, and I do add-ins. And there's an add-in model in AX where you can write tools that provide useful information to customers as they use VS. There are some templates there. You can either have global ones that live here in the add-ins that are not assigned to any particular type of artifact, or you can do it so that they work on tables in my case here. So there is one called Select in SQL Server Management Studio. And this is something that I wrote for another occasion. I put it on GitHub so that you can download it and run with it. And it shows lots of examples of how to use these metadata APIs that I talked about. So what's going to happen now is it's going to run, and it's going to open SQL Server Management Studio and connect. And it opens this. Oh, come on. There. It opens this view. So what happened here? Well, first of all, it does a select statement, but it uses the titles of the fields here so that you get a natural view of, for instance, name actually turns out to be accountant name, right? CRC, expiration date, I don't even know what that is, but it doesn't matter. So when I do execute here, oops, what did I change?
You had the string selected, you got to run it again.
Oh, I'm sorry. Okay, like this. There. So you see that now the titles are like this. And it works. See, this is a very simple example, of course, right? But it goes much deeper than this. It does mangling of field names. It does supertype, subtype analysis. It does even extensions are factored in correctly into this. So there's a whole set of analysis that goes on to build you the select statement that you want here. The idea, of course, is that you would use this as a basis of your own queries and put in where clauses and stuff to build these more advanced queries. I often find that developers are complaining a little bit about the ways that they can filter the data when they're developing their stuff, and this is one attempt to solve that problem. But the reason I'm talking about this, of course, is because the implementation that you can find on GitHub, I have it in my references, uses these metadata APIs a lot. So let's leave that open for another time. There. Yeah, I did that. But there is an easier way. There is an easier way. How many of you have ever heard the concept XML Database? 2.5 people down there. So this is not a well-known concept, is that correct? Many of you have not heard the term XML database before, right? Yes, you haven't. So this is my opportunity today to introduce you to the wonderful world of XML databases. So you all know about relational databases that are built on tables and rows and so on. But there are other databases that you can build. You can build document databases. You all know those, right? There's many different varieties. Microsoft has one called Document DB. There's more common ones as well in use. But this one is an XML database. So I'm going to show you one called BaseX. It's extremely powerful. It's free-ish. You can query documents using XPath and XQuery. And this is really important because XQuery is a query language, just like SQL is a query language over relational data. Then XQuery is over structured data like XML. And herein lies an important key. This is crucial to our discussion as we go along here, because we will be using xquery for many things in our little conversation that we have today. And I'm going to show you what it looks like, and you'll be happy with it, I think. And by the way, the BaseX thing here is a server. It has a front end that I'll show you now, but it talks to a server, and you can use that from your AX code as easily as anything. So you can incorporate this in business logic. If you have a business logic that relies on a lot of XML files, then you can absolutely use this. It's not restricted to these scenarios that I'm talking about here. So that's very cool. Let's try and see what happens here. Okay. So what I did was I went into database. I said new. And then it said, okay, you want me to build a new database for you. Which XML documents would you really like to add to it? And being a simple guy, I said, here's the root of my metadata directory. Now please consume all those XML files and come back when you're done. So it'll go there and it'll look at all the XML files and it'll build its indexes and it'll do all its stuff that databases know how to do. And at this particular point, we will be in a position where we can do not much before I actually do this. Okay, here we go. So let's execute this. And this will give us all the tables or classes in the system. So this says, all transitively give me all classes or tables. This is a simple XPath query. It's not very useful maybe, but it gives you a sort of an understanding of what it does. No, not this one. This one. Let's see what the fields are in this table. YMO. And you have all the information here. You have the type as well. You have the name, extended data type, whether it's visible or not, and all that stuff. It's all there because every piece of information that you put in this thing is available in the XML file. It's all there, right? So you can query about everything you could possibly want. Let's get rid of this guy. So here we say, this is the first time we use xquery. Say for all the tables we have, where the developer documentation is this, order them by name and return this particular thing here. So let's do that. So now I can go ahead and generate XML documents as a result set of whatever is in my XML database. And you could generate HTML from this as well if you wanted to build reports based on this, right? Is that cool or is this cool? So what have we accomplished here? Let's step back a little bit and think about what we've accomplished. Let me just see if we have any more interesting stuff here. Oh, so what are all the developer documentation texts? Yeah, so what? What have we accomplished? We have taken the metadata out of the realm of XML files that we understand using the Application Explorer. And we've taken it into the realm where we can do queries over it just as easily as you can using T-SQL over relational data. You know, I'll step back here and take 15 seconds and be quiet so that you can think about what that means, how cool that is. Okay. That's 15 seconds gone right there. But you see that you don't have to. The problem I have is that people come into my office and say, I have this question over metadata, and I don't know how to find the answer. Could you please build me a program that finds it for me? And whenever you hear questions like this, you say no, because I have a query facility where I can just do a query. Just as I can find a customer by using a SQL statement, I can use an xquery statement to find a piece of metadata. Now is the time I should see your eyes sort of light up a little bit and say, yes, I understand this. Yes, I understand this. Yes? Do Americans learn about Socratic tradition and of Socrates and Plato and Xenophon and these guys? Is that part of your curriculum in school? No, I guess not. Okay, you know what? I'll just drop that point and move on to something else. Let's see, that was fun. Okay. So just a few more points about XSpace. It's fast. It runs on the Java VM. You can download it. It has a very small footprint. There is this UI that I just showed you, which is very, very useful for doing these sort of queries. It's almost like the SQL Server Management Studio, except it's for XML. But it does have a client-server architecture so that you can talk to it via REST, I think, a REST API that you can use from X++ if you should so desire. Okay, to that. Reasoning over code now. So that was sort of my metadata spiel. Now we'll talk about code, your X++ code. Now, one of the primary tools we have that is the cross-reference database. And you may remember, some of you, back in AX 2012, we had this insanely complex set of tables that defined how things interacted and so on. When we went to the new version, AX7, we said, you know what, I don't even remember the scenarios that we were going to satisfy with all these different tables. Let's just get rid of them. Gone. I'm not going to do this again. And then we put in 2 tables that now are 3, I think. I have a names and I have a reference table. That's all. That establishes the connections that we need. So when we do compilation, we, as I said, at great expense, great cost, populate the cross-reference database. In fact, I will let you know that during a full compile, the 40% of the time that is spent is actually spent updating the cross-reference. 40% of the time. So if you turn that off, if you don't need the cross-reference information, that's almost double your compilation speed. Okay, another piece of information that you may like. Okay, so the schema really is very, very simple. You have your names that define the entity we're talking about, and you have a references that establishes the mapping and says, this thing calls this thing, or this thing extends this other thing, or so on. So there's a number of things that the relationship that can hold between these two. There is one thing I didn't put here, which is there is a relationship also to a modules table that specify what package a thing is defined in. I didn't want to go there now because it's just noise, but there is that. If you look at the tables, you'll find that as well. The cross-reference database. Okay. Let's see. Cross-reference database, he asked. Okay, here we go. So here is my databases. Here is my Dynamics XRefDB, my tables. And here are the names and the references. The names and the references. These are the ones that are interesting. If you look at the references that establishes the connection between the names, for a full build system, there's 14 million rows. So you can understand why it takes a little bit of time to populate that data. There's 14 million lines in that particular table. Let's just take a look at what the names look like. Let's get rid of this. So we have these paths which uniquely define a particular artifact. So a view with index test, no index, blah, 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 methods, and so on. Those are the names, and there's a module ID that specifies, is a link to the actual package in which it's defined. And there's something, a provider ID, which is basically not used, so I'm not going to talk about it now. Let's do the same thing for references. There, 1,000 rows. And this looks a little bit cryptic, but in fact it's quite easy. So there's a source ID and target ID. These relate to the IDs that I just showed you for names. And there's a kind, which is a number here. I'll show you a little bit later how that works. And there's a line and column because that's often used. Okay? So, let me get rid of this, this, and this. So let's see what we have here, what we can do. View script as alter. Let's do that. So for you, for your viewing enjoyment, maybe, I created this view called dependencies because it makes everything much, much, much easier in the discussion that we're going to have in a few seconds. So this does the joins to the tables that I showed you so that you can do interesting stuff like I'm going to show you now. Select. Oh. Oh no, wait. Better, okay. Okay, so let's take a look at this. I hope you can see it well enough. Come on. There. So here we have embodied the source path and the module in which the source resides and the kind. And I took the opportunity to expand this so that it's not just numbers 1 to 7. Here you can actually see that this class extends this other class. The relationship is completely clear. These are type references. There are method calls as well here somewhere. But the point is, with this dependencies thing, you can really do a lot. You can do, say, where source path, like let's try this. So here is everything that goes on with run-based batch, where we are the source of information there. So this is the sort of thing that IntelliSense does sometimes when it needs to look up stuff. But you can do the target path as well. It's completely symmetrical. Takes a little longer for some reason. Maybe I shouldn't have used 2 wildcards in the like statement, but that's what it does. Come on. There. So you can see how this works, right? With this dependencies thing, the joins, you don't have to worry about them because I already took them into account, and you can do symmetrical queries across the thing. So let's say that you are doing sealing, for instance, and you want to know which calls go from one module to the other. Well, it becomes as simple as select Okay, I'll just do top 100 here. Yeah, I'll get to it. Maybe it would have been a really good idea to have this done in beforehand, and I did, but the file disappeared, so I apologize for that. So this is going to run for a while, but this will find everything that crosses this boundary of the platform. Sorry, the boundary of the package. So you see how this becomes more and more useful, right? And you can string these things together as you wish, doing queries with where clauses over what you're interested in, even using wildcards. That's a strong value proposition, I think, dependencies. As I said, I put in a table called kinds, just for your, that just shows the kind and what it maps to in clear text. So I could have done stuff where I said where kind equals calls, I think it is. Let me just check. Method call, sorry. So in this case, I only want the cases which the wrong quotes, first of all. You see, I can actually do this with a little practice. It works. There. Okay. I'll stop here before my luck runs out. So you can see how you can do this quite easily and mine the metadata, and it's very, very useful to understand the dependencies between your source code. I'll make sure that these dependencies and so on are available to you. As we go along, you'll see how this plays out a little bit more. But let's go back to this a little bit. Yes, sir.
Is that all already available in the development environment?
No.
Did you create that?
I created that, but it'll be on GitHub so that you can download it, along with another program that I'm going to show you in a few minutes. It's part of that. Okay, so now you should have an epiphany. You should light up and say, no. This is a many-to-many relationship. I don't want to think about many-to-many relationships as tables because they're so complicated and they have joins and they're horrible. There is a better way to think about relationships. And what is that way? He asked knowingly. Graphs. Graphs, ladies and gentlemen. Graphs are the way where you actually represent that sort of information most easily. Take a look at your Microsoft Graph, for instance, is a perfect example. That will tell you all about the mails and recipients of mails, and it'll link every piece of information together. It's a graph. There's social network graphs as well that you can use. Facebook has them. I believe you can publish them. All of these are graphs because it's a very, very natural way to think about these relationships. So in this case, it would look like my class some method calls, or whatever that relationship was, something else. And now we will begin to attack the problem of understanding your source code in terms of what graphs can do for us. This is going to be fun. I just gave you some examples of graphs, just for the heck of it. So let's interest ourselves with the one over there, this guy. So there is something that you can do to a graph where you want to say, show me modularity in the graph. So build me superclusters wherein everything calls each other, or where everything has a relationship to every other node. Okay, that's useful, but how does it relate to AX or to source code? Well, if you have classes that call each other in that way, maybe you have a question to ask whether this could be one class. If they're so interdependent, and especially if the number of lines going outside of the thing is small, then maybe there's some refactoring that you could do to bring that back in line. So we've used a graph terminology and graph algorithms suddenly now to reason over dependencies that apply in source code. Wow, okay. So, let's see, going back to this guy I don't need anymore. So, thinking about this, I decided to write myself a little program, as I often do, that reads metadata in this case. I'm going to show you some. Come on, work. There. So, this is so slow, come on. Here is the actual piece of code here I create the view that I talked about before, and then down here I'm going to actually use it for something. So I'm going to fire off this query that you see here. Get all the information from the dependencies that I just showed you, where the target isn't labels or EDTs or enums, because I don't care about those for some reason. They're boring. They don't give me much information that I like. I'm just not a label guy. And I do the source module as application platform. So what I will do here is I will read all this information and I will build some aggregated information from that. So this information is very, very detailed. It says this method calls this method at this line and this column and so on. But that's not the information I want. I want dependency information. So I'm going to aggregate that information and say this relationship exists between this class and this class, and strip everything else away and then aggregate them and count the number of dependencies that exist between each pair, and then call that the weight of the dependency, right? Just a terminology thing. So let's do that, and then we'll see what the results are afterwards. Come on. Is it just me, or is this just extremely slow? Is it because I'm doing the presentation that I'm sort of thinking everything is slow? Okay, I read everything from the database. Now I'm going to build a graph in memory, and I'm going to do some querying over it. First, I generate a graph ML file that we're going to look at in a few minutes, and some other stuff. And then I'm going to generate some DGMLs, and we'll talk about that in a few seconds. Okay. Done. So now, let's go back here. And look at this result1.graphml, which was the one I just created. But let's just look at that. No. Before we do that, I want to see the DGMLs. So in here, I generated a set of files. Let's take one like this one. Here I did this analysis about closely bound things together. And the things in red are something that you could actually put in one if you wanted to. They all call each other. They're all part of the same very tightly bound thing. So this is one of the places where I applied these graph algorithms to get that result. So you know that there is usefulness in graph algorithms over these graphs. This one you may have been able to ferret out for yourself, but I'm sure that if you look at this, I mean, it gets far more complicated, right? You would never have been able to find this out on your own without this sort of algorithm. So, okay. But, as I said, I also generated something called results1.graphml. So GraphML, as you can imagine, is, do we do it with Notepad? Nah, okay, Notepad. I'll show you what a GraphML file looks like. So it's a GraphML, it's a directed graph, not an undirected one. And here's a set of nodes. So this node with ID, this number here, lives in this module, has this label and the same name, and it's a class. And there are tons and tons and tons and tons of these nodes. And at some point we will get down and define edges. So edges, in this case, this edge links together this source and this target. And the edge label is 16, and the weight is 16. Remember I talked about the weight, which was the number of dependencies that hold. So this file format actually defines a file. And with this file, which I wrote in the program that you just saw, you can do stuff. So why don't we do some stuff? I double-click on the thing, and this Gephi program starts. Gephi is a way to visualize big, big graphs. And I know that you will be a little bit underwhelmed when you see the result right now. It doesn't exactly look that great, right? But we haven't actually done anything to it yet. We opened the GraphML file, but let's see if we can gain some insight into the data that we're looking at. First of all, it sucks, right? So let's do a layout. I'll start this in a minute. And what you will notice is that the system will apply a layout algorithm that says that things that are closely bound by their weight are closely physically bound on the design surface. But things that are only very remotely connected will be much further out. That's what this Force Atlas 2 algorithm will do. When I start this, keep your eyes peeled on the design surface and see if you see some flotsam float out from this. I mean, there's value to this, guys. You'll see. Let's do it. Okay, so it's still boring, but at least you see that there's some stuff out here that's really a little bit hard to understand where that came from, right? You can click on these and get more information about what particular node this is. There is a concept of a data laboratory which will show you each individual node so you can dig into it on a tabular way instead. But let's not do that. But you see that there's a big mass of things in here, and there are some things that sort of straggle. And this could be because these are called from another package. I hope so, because otherwise there's something wrong, right? You don't want things here that are not called by anybody. But if you have that, then they will appear like these solitary dots out here, which may or may not be useful. Okay, let's do some more stuff. Let's shine this up a little bit. Let's show the module. No, let's first do the degree. The degree of a node is the number of things that point into it plus the number of things that go out from it. So there's an in degree and an out degree, and the degree is the sum of the two. So the average here is 3.75. Let's call it 4. So each class has in general 4 things that it either depends on or that depend on it. Whether that's a lot or not, I won't be able to say, but take a look at what this looks like. There's something here which has 900, a degree of 900. Surely that's fishy. We'll see what it is. And then the next one is 400, and then we have some stragglers, and then we get down to almost nothing very, very quickly. There's a lot of stuff that has 1 or 2 or 3 or 4. Otherwise, the average wouldn't be this low, right? Okay, that's interesting. Let's do some modularity as well. So here what we do is we take the nodes and we partition them into groups that are tightly coupled together. And we found 58 of these communities. They're called communities here. Close. Okay, it still doesn't help us much. It still sucks. But let's see if we can do something about that. So let's partition these based on the modularity class. Apply that. Okay, so now I applied a color that identifies all the nodes from the particular class, a modularity class. Right? It looks a little bit better now. You can see that there are clusters here, and you can begin to look at those in the data laboratory. You can always see which ones are part of that particular cluster. So at least now you begin to see that there are very strong dependencies within these particular groups that are all a different color now. Okay, I'm still not that happy. And you're not happy either. I can see it. So let's do this and say, let the size of the blob depend on the degree. Let's see what that works, how that looks like. Okay, so now some of them are a bit bigger. But still, I don't get a lot of insight from this. Let's see if we can do something else. Let's do this. Let's try to analyze this. So this is a different layout. And you'll notice that something interesting emerges here, right? What is that thing in the center? Remember that thing that had a degree of 900? What the heck is that? Well, it's the common table that everything sort of derives from or everything uses. So that's to be expected, I guess. Okay, so now we have another interesting view that we can look at. If I try to go and put labels on these, I can, but it doesn't make a lot of sense because it'll just clutter up the thing. So let me put on some filters and say, oh wait, kind. Let's say that I only wanted classes here. Okay, now I got rid of all the tables. And now you can start to ferret down things and look at what you're interested in by building these filters that filter away stuff that you don't want. So you say, I only want things from this particular package, and you could narrow down and narrow down and narrow down until you get to a situation where you have the information that you want that you can actually see from this particular graph. So it's a technique that's used a lot when you have a lot of nodes, and becomes quite useful. It's another way of analyzing your dependencies that you may not have thought about before. Right? Pretty cool. And this tool, by the way, is also free. You just download it and it runs, and it's great. I have some references later to show you how to do that. Okay. But we're still not happy. Or we're happier than we were before, but we can reach a state of higher happiness. There is actually a concept, just as there is an XML database and relational and document, there is also something called a graph database. How many of you have heard of that concept before? 2 or 3 out of the crowd here, not many. It works exactly the same as any other database, except that you can do queries over graphs. Now, of course, I took the liberty of entering my stuff into a graph database. So let's start that on my box. Come on. In just a few seconds, there it is. Go here. Okay, so this will wake up with a web experience that teaches you everything you need to know about graph databases and how to use the query language and so on. It's a really great experience right here. So let's do some things just to get our feet wet. Okay, run base batch. Okay, interesting, or maybe not. Let's do something a little more advanced. So here we say match AX nodes that have the name run base batch and that have a relationship, let's call it R, to another node, another AX node, and show me those results. So why don't we go ahead and do that? Oops. Okay, so that's this graph. It's still a little bit too big to use. Let's do something else. Let's say we only want the ones that have really tight dependencies, a lot of dependencies between each other. Still pretty cluttered, right? So let me do that again. Oops, sorry. And let's do the ones that only have a. So there are fewer now, but there's still oops. It's like almost too much to see these flicker. But now you begin to see some interesting things. These are partitioned in groups again. So that there's very little thing going on here between those two groups and a lot going on here. Then you can start clicking on nodes and you will see what the weights are and the IDs are so you can relate it to your data. Or you can click on the nodes and see the information there. Now there's one thing that I wanted to show you. Let's look a little bit at this particular thing at the top of the window here. This language. This language is called Cypher. And if I have a pen somewhere, I'll show you why it's so cool. So if you draw yourself a graph, right, you would typically do this. That fair? Yes, that's fair. So the language Cypher, what it does is it represents, it doesn't do the full circle, it just does 2 parentheses that indicate the circle. And then it does, to represent this up here, and then 2 parentheses again to represent the target node. And then it does a match. So here you define the source node and the target node, and here's the relationship that holds between the two. It's as simple as that. That's the power and simplicity of the query language called Cypher. And you can go on doing this. You can do, anything. Build any sort of query that you want in that language and have it find that information in the graph database if it exists. So again, I'm stretching your knowledge of query languages a little bit to something which is extremely clean and beautiful, but has nothing to do with T-SQL. It works over graph data. It's pretty impressive. There's a lot of good thinking going on there that I really enjoy. Okay. Let's move on to some real code. Let me just give you the details. It's a graph database. It runs in Azure as far as I know, so you can run it there. It has this front end that I showed you. You can certainly integrate it into your X++ code. It's a server product, so you can do that. So if you have information that is well kept as graphs, then you can absolutely use that. So how many of you know C#? Yeah, a good number. How many of you use code contracts? Guys, I don't believe this. I'm going to ask again. How many of you use code contracts? This is not good, guys. There is a concept in C# called code contracts. And it's a very, very nice thing where you can specify, non-intrusively, by the way, in your C# code, some preconditions, some postconditions, and some invariants that must apply. So if you're modeling an account, for instance, you might want to say that the invariant is that the amount here is always greater or equal to 0. That's an invariant that must hold. And in a posting thing, you would say the precondition is nothing, is true, but the postcondition is that the amount on the account is actually what was there before plus whatever you added to it. So these are things that relate to the problem domain that you're having, right? They relate to what an account is, not how it's representative code. Now that you have created those conditions, you can actually ask the system to enforce that they are always upheld. And the system will run that analysis for you. And it'll say, dude, the code that you have here will violate the actual thing that you said must always hold. This is a bug. You have to fix it. At runtime, it'll fail, but I can see this just by analyzing the code. That's what this code contracts thing does for you. So run to your web browser and download code contracts and get it installed into Visual Studio and start using it, because it'll give you a lot of insight into your code. It works best when you do it from the start, but I even took the opportunity to take my unmodified code of the X++ compiler, which is in C#, and I said, run the analysis over that code. And it took a while, but it came back, and I found 8 errors with unmodified code. 8 errors. It said, dude, here, I know that this is null, but now you're doing a dereference of it. Those were the kind of things that I found. So if our testing had been good enough and we had had full test coverage, I would have found this, but we didn't. But the system was able to tell me this up front by doing analysis just based on the code, without even putting in a single contract. So this is stuff that you need to do, guys. You need to look into this. Okay. But, we're not done yet. The best practice tool allows you to build interesting analysis. As you know, it works by giving you an AST, and then you you override some methods, and you go party on that. I won't go into it now. It's well understood how that works, I hope. But let's revisit X++ compilation a little bit. And this is where we get really interesting here. Here's why you spent 1 hour and 5 minutes. And you'll see why in just a few seconds. Go back here. So I'm going to show you how to compile X++ code in C#. There's nothing here that is not available to you. You have all these assemblies. There's nothing new. You can do this, write a console app, take these references that I put in here, the Dynamics AX references, and you're done. You can do X++ compilation. So what I have here is a piece of source code, and I do compile XPP. And the compiler works by... This mouse is really awful. by first creating a metadata provider which knows which package we're running against. Then it uses that metadata provider here, create metadata, to build an administrator. Never mind about that. But on the administrator, there's a compile class declaration method that'll return a compilation unit. In the meantime, you can put the diagnostic messages into something called a diagnostic handler, and you can collect the messages that way. And once you have a syntactically correct program, which will be indicated by CU not being null, then you can run the pipeline over this. And running the pipeline means doing all the analysis that the X++ compiler does. It does everything except generate IL code. So it'll do all the type resolution and all that good stuff. And then you can show what that looks like. So let's go down here and there. Let's actually do this. Let's do the compile, see if we get back a result, and then we'll output this. So let's do it. The first time you do this, it'll take a little longer, just as X++ compilation will, because it needs to spin up the metadata provider and all that stuff. Wasn't that bad? So let's look at this. I did a toString on the result of this. And the toString on the object model gave me back exactly the same result as the source code that I passed in. That's pretty cool. But this information this was just a toString, but let me look at this compilation unit thing a little bit more. So full name is C, that was not that interesting. Comments, there are not a lot of those. But let's see if we can find the methods. Oh, this thing sucks. Or you can just believe me. Yeah, no, you can't. So methods, there's one here, and you can go in and look at the value for that. It'll expand that, and it'll tell you this is not a client, blah, blah, blah. It's not a constructor. There's some statements in there. We can look at the statements. There are 2 of those, and so on. So this is a full object model of the code that you just compiled. How many of you know Roslyn? A few of you. It's exactly, it's Roslyn for X++. You have the full object model here. Now for the surprise. Now for the thing that you didn't know. So in the dark hours of the creation of the new X++ compiler, work was done under the radar. And the work that was done under the radar resulted in this thing that we have now hidden. So it said hidden because I didn't want to spoil the fun. So now I'm going to expand this. And what happens is that you can actually generate an XML document based on this. So let's just see what that looks like, just for the heck of it. So let's see what this looks like. You know what? I think I'm going to do... There's an XML. There. It's an enormous document. These documents are really big, but they define everything there is to know about this particular compilation unit. Okay, so we can generate an XML document. I didn't write any code that's not in the assemblies. I didn't. I just showed you how to use them. Now here's something where an epiphany should start occurring in your minds. What was it this guy said before about XML? Didn't he say something about XML databases? He did, didn't he? That I could query XML using XML databases. This is now an XML object. Hey, is there something in that? Is there something we can use here? And the answer, of course, is yes. So let me show you how that works. So before the show, I went ahead and I ran the little algorithm that you just saw that generated the XML file. I ran that on all the classes and all the tables, and I put all the results in a folder, and I said to this thing, import that. So now we're going to actually open that database. And you see the memory footprint now is much bigger because there's a lot more documents and they're a lot fatter. But it should be able to run. There. So let's... No, I don't want these anymore. Developer documentation. Oh, never mind. Let's do this one. So, for all the classes where the count of fields is greater than 20, order those and build this document for me. Come on. Come on. Please. You can do this. There. So all these classes have more than 20 fields in them. It's a little much maybe, but that is what it is. Let's see if we can do... No. Let's do this method in tables. Let's say that we want a version that tells us for each table how many methods it has. What happened here? Oops. That wasn't quite what I had expected, I must say. Whatever, let's move on. Let's do this one. Let's say that I wanted to know for a particular thing, where were the post handlers for this particular delegate? Guys, how would you find this information in any other way? Tell me, how would you find this information? By doing searches over the source code with a flat thing that compares one character at the time? Are you kidding? You couldn't. These are value propositions that are just beyond what you can do anywhere else. So you could do a query here that says, show me all methods that have comments that span more than 3 lines, that have a while statement in them, where I do a local declaration of a variable called I that has an initialization of the value of 5. Try to do that in any other way and see how far you get. Okay, let's... So here's one where I check for while statements. This is just for the heck of it. Let's do it. So give me all classes that have a while statement as the first statement in there. There. These are the ones. But let's do something really scary. Let's look at methods that have OR expressions in them where one of the children or both of the children are Boolean literals. Why would you ever do an OR with a Boolean literal? That wouldn't make sense, right? I mean, why would you OR false, for instance? And if you do OR true, why have the OR at all? So there's something wrong if you do that. So let's do it. There. So what it'll do is it'll find these 2 cases. And it's a little hard to see here. I won't fish out the information for you. But one of them, there are 2 classes that have methods that do this. And the code that you see here is the actual code that this query found. This is production code. How would you have found this otherwise? Of course, I didn't remove it because I wanted to have this class here, but how would you find stuff like this? How would you do granularity at that level? It's just not possible with any other way. Right? You see the point? You see the power? Yeah. Yes, you do. Great. I love it. Okay. So let's get back to this. So now that you have the code, you can query it. Think of this as declarative best practice rules. Remember I said that you had this best practice framework and all you had to do was to write some code where you override some methods and do some analysis and all that stuff. Yes, you can certainly do that and it's great. But what if you just wanted a one-off? Then the cost would not be worth it. But what you could do is you could just write a query over it, just as you can find a piece of information in your SQL database. You can find a piece of information over your code. Exactly the same way. And it wouldn't take you 1/10 of the time. So, as I said, the details are enormous for whatever you can do there. So there is one more thing that I want to talk about. There is a similar product for C#. It's called ndepend, and it will allow you to do queries over C# code in much the same way. It has a different syntax. It uses a link syntax to do this. I could have shown this. It's also very impressive, but I didn't want to do it because once ndepend has looked at your code, it looks at the IL code that the X++ compiler generates. And there's a loss of fidelity between those two. It doesn't know that this piece of code corresponds to a search statement, for instance. This particular way knows all about the semantics of X++. So that's pretty cool. Yeah, I think that's it for today. Thank you very much.